Hello everyone, welcome and today we are going to discuss vectors. Vectors क्या होते हैं इसके बारे में हम लोग डिटेल चर्चा करने वाले हैं, तो पूरे वीडियो को देखें और जिनको भी वेक्टर्स में कंफ्यूजन है उनके लिए ये काफी हेल्पफुल होने वाला है। जनरली इस वेक्टर को कवर करने में लगभग 2 से 3 लेक्चर्स लग जाएंगे। ऑलमोस्ट मान के चले कि 3 लेक्चर्स लग जाएंगे, उसके बाद वेक्टर्स को हम लोग 4 भी लग सकते हैं। उसके बाद वेक्टर्स को हम लोग थोड़े अच्छे तरीके से जान पाएंगे। सो विदाउट वेस्टिंग एनी टाइम लेट्स स्टार्ट वेक्टर। सो हमारे पास जनरली जो फिजिकल क्वांटिटीज हैं वो 2 पार्ट में डिवाइडेड है। ऑल द फिजिकल क्वांटिटीज आर डिवाइडेड इन 2 पार्ट्स। तीसरा पार्ट भी है जो हमारे इस पोर्शन के लिए नहीं है। सो वी हैव वेक्टर्स एंड स्केलर। ध्यान से समझेंगे हम। सो व्हाट आर वेक्टर्स? अगर अभी बात की जाए तो वेक्टर्स को अगर डिफाइन किया जाए तो दोज फिजिकल क्वांटिटीज और those quantities those physical quantities those physical quantities which have magnitude and directions we'll discuss in just about after 1 minute what does it mean। हम लोग अभी थोड़ी देर बाद समझने वाले हैं। एंड फॉर स्केलर इफ वी वांट टू स्टडी, सो स्केलर quantities are the quantities which have only magnitude means to specify these quantities we don't need to specify in what direction, we don't have to specify. For example, let us assume Changu is standing at a particular place. Let us assume he is standing here, and if I say that Changu starts to move and he moves by a magnitude of 5 meter. He moved to a magnitude of 5 meter. Or I'll just say that Changu has moved to 5 meter. Changu has moved to 5 meter. 5 meter. But in which direction? I have not specified in which direction he is moving. So if I say the Changu has moved by 5 meter, he might have moved to the right direction, to the left direction, upward direction, downward direction, into and out to in any direction he might have moved. But I have said just that he has moved by a distance or by a distance of 5 meter. All right. But if I say that Changu has moved by 5 meter in a right direction, now I have specified the direction also. All right. So if I specify magnitude of the vector as well as its direction, if I specify some physical quantity with its magnitude and direction, which means that this particular quantity is a vector. For example, displacement, that particular displacement, right? Displacement, and this is distance. So if for scalar quantities, we just have to specify the magnitude. But for vector quantities, we have to specify the magnitude as well as the direction. All right. Same, you can take example of masses. Mass is a scalar quantity. You can take example of current, you can take example of work, energy, and for vectors we'll study what are the different quantities. All right. So if I say how fast does Changu has moved from one position to another position, how fast it has moved. Let us assume while covering this distance, he has taken a time of 3 seconds. 3 seconds. So I'll say that that Changu has covered a total distance of 5 meters in a time of 3 seconds. So I'll say this is he has covered a distance of 5 meters in a time of 3 seconds. In a time of 3 seconds. So by specifying this, I have not mentioned in which direction he is proceeding or in which direction he is moving. So if I have not mentioned in which direction he is moving, then it is a scalar, and that particular quantity is speed. But if I say that he has moved to a distance of 5 meters in a rightward direction in a time of 3 seconds, it means that I'm specifying his velocity. So its velocity is 5 by 3 meter per second in right direction. In right direction. All right. Next is how do we represent or how to represent a vector? Represent a vector. But before that, I think I should mention one point also in the vector and scalar. First point is scalar are the quantities which have only magnitude. Correct? Vector are the quantities which have both magnitude and direction. Second point is they follow vector law of addition. Why does it important? We'll discuss in the future. Vector's law of addition. Addition. And for scalar, they follow simple algebra. Algebra for its addition. For addition purpose. All right. So next is how to represent a vector. Generally, the vector is represented by an arrow. This is the arrow. So this is head and this portion is tail. This is tail. This head of the vector. The length of this vector or this arrow represent magnitude of the vector. Whereas this arrow pointing denotes the direction. This arrow denotes the direction. For example, in this scenario, it is pointing towards right. All right. So vector is represented by an arrow. It is represented by an arrow. The length of the vector is represented, or it is given by the the value of magnitude of the vector. The length of the vector gives the value of magnitude of the vector, whereas its arrow represents the direction. Its arrow or the head represents the direction. All right. So, next. Suppose, for example, I have some cases. Let us assume I have given first point is find out vector. Question is find vector and scalar. Find vector and scalar. Vector and scalar. All right. First, 5 meter. Second, 30 degree. Third, 2 comma 5, 2 comma 5 or 3 comma 5, whatever, or 3 comma 4. Okay. So out of these, which all are vectors and which is scalar? Let us assume I have this x and y. If I say 5 meter, I have just specified the magnitude. It can be here, it can be here, it can be here. So it can be anywhere, which means that this is scalar. Scalar. If I say the angle is 30 degree, but I have not mentioned the magnitude of the vector, in the second case, I have just given the direction. So this is also not a vector. Now, if I say 3 comma 4 point, so this might be 3, this might be 4. So this is point 3 comma 4, 3 comma 4. So basically this is 4, this is 3. Now, if I have to find out the magnitude of the vector, this is my magnitude, which will come from Pythagoras 5, and this angle is theta. This angle is theta. We know that how much this angle is. This is basically a 53 degree. So this is 53 degree, which means this is a vector quantity, which means this is a vector quantity because it has both magnitude and direction, right? And in the next section, we are going to discuss what is position and displacement vector. What is position and displacement vector. बहुत बढ़िया. Displacement vector. Displacement vector. Displacement vector. बहुत बढ़िया. बहुत बढ़िया. आइए. Let us assume again I have this x and y axis. Why, sir? Why you are always taking x and y axis? Because to specify any position, we need a set of coordinate axes. That's why I have taken x and y as my axes. Now suppose Changu is standing at some particular point. So he's standing, suppose, at this point P. Now I can specify its position by either telling that it's coordinate x comma y, or I can generally specify a vector whose magnitude I can find and with the some angle from x or y axis. So this vector is representing a position vector. So what is position vector? Position vector. अच्छा, नाम ही बता रहा, पोजीशन वेक्टर. तो पोजीशन वेक्टर क्या होगा बेटा? It's a vector. It is a vector. It is a vector. It is a vector which joins origin and which joins origin and position of the object. Position of the object which is directed from from origin to that particular point. Next, if this person or Changu starts moving and he starts roaming around, and after some time has reached to a particular point in which the coordinate is x2 comma y2. Suppose this point is Q, which is x2 comma y2, x2 comma y2. So this particular distance or this particular vector, I'll use some other color. This particular vector, which is now originating from the first position or from the point P to the point Q, is called the displacement vector. Right? It's called the displacement vector. So if I say displacement vector, displacement vector, it means that whenever a particle moves from one position to another position, then a vector which is connecting, or the vector which is connecting the starting point and the end point, is called the displacement vector. It's called the displacement vector. So I can write it when an object or particle is displaced from its position, is displaced from its position, is displaced from its position at a particular point from its position P to a new or another position Q. Another position Q. Then QQ vector represents displacement vector. Represent displacement vector. Okay. Next. So if I say he has moved from, or the Changu has moved from path A, and Mangu has moved to the same point in another path. It is not visible. That color is not visible. So I'll use again. Some another path and reached to the same point. So is the displacement of both Changu and Mangu same? Yes, sir. It is same. Is the magnitude is same? Yes, sir. Bilkul the magnitude is same. Is the direction is same? Yes, the direction is same. Which means that displacement vector between any 2 points, displacement vector between any 2 points does not depend on the path followed. On the path followed. All right. Next. Now, what are equal vectors? Let us assume I have two vectors which has exactly same magnitude, and both are moving in the same direction. For example, this you can visualize that suppose you are moving inside a bus and the bus is moving towards right. In the same time, another bus or another car starts moving parallel to each other. And at all the time, you can see the person sitting in the other bus or other car. which means that both have same magnitude of velocity and they are moving in the same direction. So these two are the equal vectors. So if I say what are equal vectors, these are the two vectors which have same magnitude and points in the same direction. We can write equal magnitude and points in the same direction. Points in same direction. Same direction. Points in same direction. Correct. Same direction. These are called equal vectors. These are called equal. These are called equal vectors. For example, here A and B are equal vectors. Now, sometime you might have heard the term free vector. What is the free vector? What is free vector? Free vector. So, free vector is a vector. Free vector is a vector which move parallel to itself. So, this vector can be moved parallel to itself. It can move in this direction. It can move parallel to itself here also. All right. So, if a vector can move parallel to itself, which means that it is the same vector only because the direction has already not changed and the magnitude is the same. So we call these type of vectors as free vectors. So if a vector is moved, if a vector is moved parallel to itself, if a vector is moved parallel to itself, it represents a vector equal to itself parallel to or equal to itself. These are called same vector. Since these vectors can be moved freely, क्योंकि ये vectors freely move कर सकते हैं parallel to itself, ये freely move कर सकते हैं parallel to itself move कर सकते हैं freely, since these vectors can be moved freely or freely move parallel to itself, these are called free vectors. These are called free vectors. Next. Now let us assume if I multiply my vector with some particular quantity or particular real number. So multiplication of a vector by any real number. So let us assume I have this vector. Let us assume its value is 2 meter, pointing in the right direction. Now, if I multiply this vector with some real number. Suppose I have multiplied it with 5. So its magnitude will become now 2 into 5, which is 10 meter. But its direction will remain same. But its direction will remain same. So what happened if I multiply a vector with any positive number? So if n is positive, a positive number, if n is a positive number, if n is a positive number, then then if we multiply, then if we multiply, then magnitude will change, but the direction will remains. Let us assume if I multiply it with some negative number. Now, this is my a vector. I have multiplied it with some minus a or minus 5 minus n a m. Now, if I have multiplied this a vector with some negative number, then its magnitude will change by n times, or magnitude and direction both will change. Magnitude and direction both will change. Let us for the third case. Let us assume for the third case, I have multiplied a vector a with 0. Whenever we multiply a vector with 0, so what will happen? What will happen? If I multiply it with 0, its magnitude will become 0. So the magnitude of this vector, magnitude will become 0. 0. So these vectors are called null vectors. These are special type of vectors which has a magnitude of 0. It is called null vector or 0 vector. Null vector or 0 or 0. Null vector or 0 vector. Next is unit vector. Unit vector. As the name says, it's a vector whose magnitude is unit. It's a vector whose magnitude is unit, whose magnitude is unit, which means 1. But it is used to specify the directions. It is used to specify the direction. So what are the unit vector? Unit vector is a vector whose magnitude is unit, and it is generally used to specify the direction. So suppose I have this vector, its magnitude will be equal to a. Okay, its magnitude is equal to a, and its direction is given by a cap. So a into a cap. A cap is basically a unit vector of a. So a cap can be written as a vector upon a. A cap can be written as a vector upon a. Now, in a similar way, we have made something called unit vectors in x, y, and z axis. So I represents unit vector in x axis, j unit vector y axis, and k unit vector in z axis. Unit vector in z axis. So I, j, k are unit vectors यूनिट वेक्टर का मैग्नीट्यूड कितना होता है? इट्स मैग्नीट्यूड इज यूनिटी एंड इसका पर्पस सिर्फ एक काम है, क्या? कि आपको ये डायरेक्शन बताता है। ठीक है, आज का कार्यक्रम यहीं तक रखते हैं हम लोग। इसके आगे नेक्स्ट वीडियोस में हम लोग एडिशन सब्सट्रैक्शंस ऑफ वेक्टर्स पढ़ेंगे, जिसमें हम लोग ट्रायंगुलर लॉ ऑफ वेक्टर एडिशन, पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन भी पढ़ेंगे। उसका स्केलर प्रोडक्ट एंड वेक्टर प्रोडक्ट भी पढ़ेंगे। ठीक है, फिर बहुत सारे न्यूमेरिकल भी करेंगे। तब तक के लिए बाय बाय, टेक केयर, धन्यवाद।